Hey guys, and welcome to day 18 of Integral a Day. So today we have this function here to be integrating. And as I did over on Derivative a Day for today's video, I plotted the graph and it ended up being real awesome to see how the original function and its derivative looked. So I'm going to do the same for today's integral and see how that ends up looking. It's really cool to see a visual representation of what we're actually solving here. So yeah, stick around to the end of the video to see that. Now, when integrating this here today, where my first thought whenever going into a question that sort of looks like, has a multiplication there, has powers, especially when it comes to trigonometric functions now, my first thought is U substitution. And I also think which trig identity out of all the terms here will allow me to have the most of one sort of function. So in our case here, the derivative of tan, the derivative of secant is, so if we make u equal to secant of x, then du is going to end up being, as we did the other day here on the channel, tan x secant x dot dx, which will actually end up allowing us to get rid of tan and keep our secant of x. I'm jumping the gun here a bit because while we're doing trigonometric functions, I have been solving them beforehand. So that was just a bit of a look forward as to what we will be doing here. I was just showing you my thought process. Now, for some reason, and I still haven't, I guess I've just been lazy and actually haven't figured out why we only like even numbers when it comes to dealing with powers and trigonometric functions, but everyone seems to do it. I don't like doing things without understanding it though, so as soon as I find out, I'll let you guys know, or if any of you guys do know, please tell me in the comments section. But we can make them to be even, our powers here, just by pulling one of them out each. Now this here can be rewritten. Since we only want secant of x and we want as little of tan of x, so we can use our u substitution. We're going to, let's finish this here. Du over tan x secant x. That's just our normal procedure. We rearrange it so that we can substitute du in for dx. Now we can use this cool trigonometric identity I learned today while doing this, and that is tan squared x is equal to negative 1 then it was plus, I think it was secant. Yeah, well, we would want it to be secant of x. No, that's wrong. It was secant squared x. And now we can actually substitute, well, here, how we can get tan squared x. And this is how, like, you got to keep a real open mind while solving these, is you have to be thinking, how can I manipulate this so that I can use an identity in order to make it easier to integrate? And here we can see if we do this and square that, we get our, we can now make this just secant. Secant x tan x dot dx. Now let's rewrite this again so that we're using our trig identity now. -1 plus secant squared x squared times by secant x. I don't know if I say, is it secant? I think that's how you pronounce it. Dot dx. Okay. Now from here, we can now write it in terms of u and du. So substitute those values in so that we can, so we got u to the power of 8 times by -1 plus u squared, all that squared. And then we have u here, which we could have kept as u to the power of 9. One of them's just about to cancel out here. But we still got this tan x, which we don't want, because we can't derive that nicely in terms of u. And it's du over tan x. And secant of x is now u, which is exactly what we want, because I always like using red for this. These cross out, and we're just left with this here, and we're integrating with respect to u, which is awesome. That's the whole point of manipulating the whole function. That was a pretty good match. I can see a little bit of a difference in tone there, but little things. .du. And now we can just simplify this here so it's easier to integrate by expanding it. So now we just can't do this here. We need to use the distributional, which is space is a currency on this channel. There we are. We'll take that space, which is a squared plus 2ab plus b squared. That is a very handy thing to remember. Definitely remember that. Now we're going to let a equal -1, our first term in here. We'll let b equal u squared. Now we can just turn this here into this. So I'm just going to do that as we go here. So that's going to leave u8 out the front. -1 squared will just give us 1. Positive 1. 2ab, well, that'll be -2 u4. I assume no, it isn't. It's just ab, which is u squared, and positive. Now it's b squared, which is u squared. Using that exponent rule, we'll get u to the power of 4. dot du. And now we can just do that here, expand out like so. I wonder how we might be able to fit this in. Let's go for gold. So it's U8. You would not there. U8 negative 2 U8 plus 2 would be 10. And then positive U12, I assume. I just don't want this to be the downfall here. What did I get earlier today? We'll find that. Oh yeah. So this is what we had earlier. We got that right. Good. And now that's just the reverse power rule, which is I find that as a bit of a pat on the back when you can get it down to this stage. It's always really satisfying to simplify it down this far. Now we're not integrating anymore. We're doing the integration part here. So negative 2u11 on 11 plus u13 on 13 plus c. Now I'm going to bring the constants out the front of each term and substitute, well, resubstitute secant x in for u as I write this now. So 1 over 9 secant. Now can't forget that power. Now it's no longer u, it's x. 2 over 11 secant 11, oh dear, x plus 1 over 13 u dot, no. Sometimes my brain just likes to not function properly. I'm just looking at the final answer I got earlier, and yes, that was the answer that was verified earlier. Let me know in the comments if this is what you got, or if you got a different answer and how you got that. So I'd be interested to hear how you did that. But I'm really keen just to plot this now. So I'm going to be using Desmos. As I said in derivative day, my channel is way too small to even think about getting sponsors or anything like that. So that's definitely not the case. Yeah, I use this software as I use Symbolab for my actual uni assignments. So since they've helped me, I'm going to help them. The software here really does help. Why? What's your problem? Only? Oh, okay. No, okay, so Desmos doesn't like, only like secant squared and secant negative to the power of -1. However, we can plot our answer. Bummer. X and C are way too close to my keyboard. To the power of 9. X 2 11 secant. No, to the power. Oh no, we're gonna have the same problem. Okay, well, another one I do use that we'll try in tomorrow's video is that's one my maths tutor at school used to told me about, and it's really good. I'll look for it quickly. Windows, give it a quick mention. GeoGebra. It's a desktop application. We'll try that next time. It was free when I got it. GeoGebra is also really good. I just find the GUI of this, yeah. Oh well, we can't plot it today. However, if you got that answer, good work. If you got a different answer, let me know in the comments how you got it. And yeah, hope you all have a lovely day or night, depending on where you are. And I'll catch you here tomorrow for day 19.